Solving equations and inequalities with absolute values. So the objectives, again, is just solving for the absolute values, equations with absolute values, and we're going to solve inequalities with absolute values. So this statement tells me that for A is greater than 0, meaning that A is all positive number. Because if it's greater than 0, then we know it's a positive number. We're going to use the algebraic expression of x. Then we're going to say the absolute value of x, and my apologies that it should be a straight up and down line like you see right here, is equal to a. A here is positive number. Then we're going to get its opposite. And what do I mean by that? If I draw that on a number line, and let's place 0 here, and let's put a positive a here, we have this distance from 0 to a. That means we're going to have the same distance from 0 to the negative value, the opposite of it. So therefore, we will have two answers here because the absolute value is equal to a positive number. It's true. If the absolute value over here is equal to 0, we're going to have one solution, right? Because it occurred at 0. If the absolute value is equal to a negative number, and this was given to you from the beginning, then this is not true and we don't have any solutions. Now, there's going to be times there's more stuff going on that we will get one value, but it's just going to be at a specific point. We'll get to that. This one here says absolute value is equal to 5, a positive 5, so it's true. So I know I'm going to have its two values. And if you notice, they labeled it from 0 to 5 is one set distance. And since this is a true statement, we're going to see the same distance in the opposite direction. So x is going to equal -5 and x is going to equal +5. All right, now I have absolute value of x minus 3 minus 1 equals 4. So that absolute value is not isolated. So what I'm going to do is I'm going to add this 1 to both sides, right? So I can get it isolated over here. So now I have absolute value of x minus 3 is equal to 4 plus 1, which is 5. Now we can look at it. And another thing is to look at too, make sure the absolute value here has a positive 1 coefficient, and in this case it does. If it didn't, we still have another step to go. Okay, so this is a good true statement. It is a positive 5, so I know that I'm going to have two solutions. So what I'm going to need to do is solve for when it's the positive 5, but I also need to come over here and solve for when it's a negative 5. So now I'm going to drop the absolute value and let's solve for it. Since it's a -3, let's add it to both sides. So now I get x is equal to 8. Let's do the same over here. Add the 3 to both sides. Well, -5 plus 3 is going to give me a -2. So I have my two values when x equals 8 and -2. I got carried away there. Let me erase that. Looks like a 3. -2. Okay. Now we want to check the possible solutions. We're going to make sure that they're true solutions, right? So what you could do is plug it back in to the original. So what do we have? X minus 3 minus 1 is equal to 4. And let's plug in when x equals -2. So I got the absolute value of -2 minus 3 minus 1 is equal to 4. So this gives me what? -5 minus 1 is equal to 4. Absolute value of -5 is 5. It's positive, right? When you pull it out of the absolute, it becomes positive. And then 5 minus 1 is 4. Oh, perfect. That's 2 works. Let's try 8. So I got absolute value of 8 minus 3 minus 1. Well, 8 minus 3 is 5. And we're going to pull it out of the absolute value. It's positive already. 5 minus 1 is 4. Oh, perfect. True solutions. Let's move on. Okay. When A equals 0, the absolute value of A is equivalent of X equals 0. This is where I was stating that you'll have one solution. Note that if A is less than 0, then that means it's a negative value. Then there's no solution because it's an empty set. You're telling me that some absolute value of X is equal to a negative number, and that's not true. Okay? So now it says inequalities sometimes contain absolute values notation. The following properties are used to solve them. For A is greater than 0, so it means it's all positive numbers. And an algebraic expression, we get this expression. It says absolute value of X is less than A. It's equivalent to negative A, or X falls between negative A and A. Okay? If X is greater than A, so now look, we're using inequalities, okay? So if X is greater than A, then that means we're going to have a negative A and an A. So let's just solve these and maybe I'll make better sense. This inequality means less than or equal to. This is greater than or equal to. So if I have an absolute value of X that's less than 3, then this tells me X is going to fall between negative 3 and 3. If I have Y is greater than or equal to, because the equal to sign here, 1, then I know that X, or excuse me, Y, so let's look at it right quick. I know that I'm going to have two values because it's greater than. You see it? Y is greater than 1. So it's telling me this statement here, Y is greater than 1. However, since that's a true statement, we're going to have to find its opposite, its negative. And if you do that, since it is an inequality and you're forcing a negative across it, the inequality flips. Okay, so that's what happened there. It flipped. Here it said X is less than, so that means X is not going to be bigger than 3. Therefore, it's not going to be on the other side of the negative 3. It's going to fall between them. Here you go. You have 2x plus 3. All absolute value is less than or equal to 4. So this is telling me since it's less than, it's going to fall between the positive 4 and its negative value, its opposite value. It's going to fall between them. So solve the graph, the solution set. So what we want to do is solve the solution set and we can graph it. Okay, so I have 3x plus 2 is less than 5. So that means this absolute value is going to fall between 5 and its opposite, right? So I'm going to set it up like this. And let's solve for x. Well, I need x by itself, so I'm going to subtract 2 from all parts. Remember, you got to do it from all parts. Can't, what you do to one part, you have to do to the other. Negative 5 minus 2 is a negative 7. 5 minus 2 is 3. Now, I'm going to divide by this 3 because I want a positive 1 coefficient on x. And what you do to one part, you do to all. So now I got 7/3 is less than x. 3 goes into 3 once. So if you'll notice here, since there is no equal signs on these inequalities here, they're going to be a parenthesis. It's usually an open circle, but in this case here, we're just using parentheses. And if you notice, this negative 7/3 is right here. It's got a parenthesis. X is falling between it and 1 has a parenthesis. If it has the no equal sign with it, it means we're approaching those points, right? But if it has an equal sign, it says we're exactly on that point and so forth. Okay. It had some, set builder and interval notation. Let's do that right quick. Let me clean this up. I want to explain this to you right quick. So we have, this is called a set builder notation. Whoops. Right here. What this tells me is that I have a set of x that builds on when x falls between negative 7/3 and 1. right? And it's not equal to, it's just falling there. My interval notation is you're always doing the smaller number to the larger number. It says parenthesis, which is correct, right? -7/3, comma 1 is telling me the same thing as this, except for an interval notation. All right, let's solve the graph. So what do we have here? We have this absolute value that's greater than or equal to 1. So it's greater than. So what I know is that I'm going to take this absolute value and I'm going to set it greater than, whoops, let me get my notation correct. I'm going to set it greater than 1. But don't forget the equal to on it. And since this is true, and since this is telling me that it's happening at 1, then I'm going to have it at the absolute value of it, or the opposite. So in order to do the opposite, I have to push a negative sign through the inequality, which means the inequality sign flips. Now let's drop the absolute value sign, and let's solve. So I'm going to subtract the 5 from both sides, so we can get the -2x by itself. 1 minus 5 gives me a -4. I need to divide by the -2 because I need a +1 coefficient on it. And in order to get the +1 coefficient, we have to divide by it. So we know negative divides negative is positive, and 2 goes into 2 once, leaves me with x. However, I got to divide this other side by the -2, meaning that I'm pushing the negative sign across the inequality, so we're going to flip it. -4 divides by -2 is positive. 2 goes into 2 goes into 4 2 times. Now let's solve this other one. I'm going to subtract the 5 from both sides. At -2x less than or equal to -1 minus 5 gives me -6. Again, I'm going to divide by the -2, and when I do that, this inequality sign flips. Negative divides negative is positive. 2 goes into 6 3 times. So I'm going to have something affecting 2 different areas, right? Let's look at when x is less than or equal to 2. So if we plot 2 here, since we have the equal sign, we have a bracket. You see the bracket? It means we're including it. And it said x is less than, so you notice it's shaded it all the way down to here. So this interval notation will be parenthesis, -infinity, comma 2, and I'm going to put a bracket. And I'm going to put a union here because I'm going to say and, right? Or we're including, we're having these points. And then let's plot this x is greater than 3. And it's equal to sign, so the 3 is going to have a bracket. So I'm going to do bracket 3, comma, and it goes off to infinity. So I'm going to put infinity in parentheses. Again, you cannot stop infinity, so you have to put parentheses with it. And we could check just to make sure. Yeah, interval notation. Good deal. And we have the set builder. Let me erase this so you can see the set builder. It's pretty neat. So if you'll look, it's or. And I said and what ago. Let me correct my wording. If you ever have, this is not this case here, but if you had an intersection, this would have been and, because we're talking about this and that. However, since we are talking about this one area versus this area, we're going to say or, this or this. So this notation is correct. This here is a set builds on x, right? Where x is less than or equal to 2, or x is greater than or equal to 3.